Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by our special guest, Dr. Mary Helen Armour. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT, if that's more your speed. York Universe works in concert with our online public viewing program run by the amazing Observatory team. So if you're online on YouTube right now watching this, the team is there. So we are running between the same hours, 9 to 10 p.m. local Toronto time, for both programs. If you want more information, you can always see our website at yorku.ca/science/observatory and follow the links to OPV online public viewing to see all of our previous episodes, or of course, click any YouTube link to join in live or see past OPV and York universes. For comments and questions, you can always email us at observe@yorku.ca. And of course, you can connect with us on Instagram at York U Observatory and Facebook at Allan Carswell OBS. All of our programs are free, but if you'd like to make a donation or buy some very cool observatory swag, you can see that same website, yorku.ca/science/observatory. Our crew is monitoring the chat room for questions and looking to post some content. The current weather is promising, so we hope that we'll be able to go live with some beautiful images tonight on YouTube. So if you are following along, stay tuned. Hopefully, it will be clear enough for us to open up the 1 meter telescope and show you some live images. Fingers and toes crossed. All right, so just as a reminder, if you didn't remember, our special guest, Professor Mary Helen Armour, she has been on this show before, but in case you missed her, she is a faculty at, she is faculty at York University. She teaches a number of science courses in the natural science division. Her background is both in astronomy and earth sciences, and she has an interest in all kinds of amazing things from historical astronomy all the way through to planetary sciences and has some very cool geology related talks. And she has, in fact, been a astronomer in residence with us out at Killarney Provincial Park. Mary Helen, welcome back to the show.
Thank you. It's good to be back. That was quite the introduction I got.
Well, it's always great to have you on, and of course, it leads into one of our announcements later of astronomers in residence starting up again this summer. Now, for tonight, we have all kinds of great things planned for the show, and of course, if it is clear, we'll be able to open up that 1 meter telescope and show some live images. How is the sky where you are?
Fairly clear, just getting dark. So I'll see what's there later. Of course, I'm just up north of Toronto, so I probably have clearer skies than you guys do, but you never quite know when you get cloud cover at the last minute because we're kind of close to Lake Simcoe, so you get some of the lake related humidity in the evening sometimes. So
Oh yeah, absolutely. And of course, I always like to say with Toronto, the weather forecast is strictly a guideline. It's I mean, really, you just have to wait and see, and maybe it'll be clear, and maybe it won't. But of course, we do have a crew standing by at the telescope, watching those clouds. So who knows? We might even get lucky. So for tonight, we have a couple great things planned for discussion. We have a couple little this week in space and astronomy histories just to get us started, and then we have some fun news items too. So I always like to start with some this week in space and astronomy history, just because it's fun to read about what went before. And so I have a little two-in-one. I figured, well, this week we have, of course, the Eta Aquarids meteor shower maximum, basically today. So, or well, last night slash today. But of course, we also have all kinds of other interesting things coming up. So I thought I would take us back in time quite a ways and talk a little bit about some extra, well, meteor shower adjacent things. So the Eta Aquarids, which were peaking on the May 5th to the 6th, very interesting, fun meteor shower. And the Eta Aquarids, sometimes spelled as Eta Aquarid, it's usually active between April 19th to May 28th every year. And this happens when the Earth sort of flies through a little bit of debris. And in this case, it's actually debris from the comet Halley. So why am I telling you this before the this week's Space and Astronomy History? Well, in the 6th of May, which is today, but all the way back in the year 1066, there was a pretty famous appearance of Halley's Comet in London, of all places. So London's Halley Comet appearance was part of the 1066 Halley's Comet passing by Earth. And this particular appearance of the comet came at an interesting time in Earth history, I suppose you might say. So there's a pretty fun little simulation you can do. So if you have the free Stellarium Web Org software, you can actually pull up a bit of a simulation about the comet on the 6th of May, 1066, which I definitely recommend. And you'll see that it was pretty huge. This comet is, Halley's Comet is known for being fairly spectacular and, of course, a regular periodical comet that comes back. And that means that we get to see it over and over again. Of course, our next chance won't be for a while. But this particular one in 1066 happened at, I suppose you'd say, a politically interesting time. So it was notably seen all over the world. And in England in particular, it was thought to be an omen. So 1066, I mean, we don't know a lot about it. I don't think any of us were around then, but there were definitely omens around, and there were some, political upheavals happening. They had Harold II die, and somebody else conquered the throne. William the Conqueror, I think it was.
Yes, it was
And
William the Conqueror from Normandy.
so his name is apt, I suppose. William the Conqueror conquered. So it was a politically significant, time of humanity, or at least especially in London. And it was bright enough to be really, really visible in the sky. And of course, they did not have the very sad problem with the light pollution that we have today. So their skies would have been quite a bit darker, and it would have been pretty spectacular. So it would have been about 4 times the size of Venus. And Venus, if you haven't seen it, it's the one that people keep mistaking for an airplane. So it's pretty bright in terms of things in the sky. Even in Toronto, if Venus is out, you can usually see it unless it's really cloudy. Now, this was without the light pollution, and on clear skies, it was about 4 times the size of Venus, but the light that it was emitting was about a quarter that of the moon. So it was really, really lighting up the sky, and it had amazing tail. There are some tapestry depictions of this. So I don't know if you have any cross interests with sewing or embroidery. There's some wonderful tapestries about this comet, and of course, it entered the historical annals because it was happening during a historically interesting time, shall we say? And of course, it was noted by a bunch of different people around the world. So it was thought to be an omen. It was put into tapestries. There is actually a chronicle, an Anglo-Saxon chronicle by the Aylmer of Malmesbury, which is a challenge to say, but that was a English Benedictine monk who has a fun crossover because he was actually kind of an inventor and tried to attempt making a glider, like a literal glider for flying. Really cool. Anyways, he also noted down the comet appearance. And there's some pretty famous quotes, but he has um, uh, you know I think the most famous one that I was able to find, at least earlier today, was William of Malmesbury. Um, so he was a historian in the 12th century, and he mentions that the comet, so this is a quote from him, so the comet portending, as they say, a change in governments, appeared trailing its long flaming hair through the empty sky, and this would have been very spectacular. And there's a fun extra to part to this because obviously as an omen it was not just impressive, it was also sort of terrifying. So he goes on to say, uh, there's a fine saying of a monk of our monastery, crouching in terror at the sight of the gleaming star. You come, have you? He says. You've come, you source of tears to many mothers. So they really, really leaned into the omen on this, and it was really a portent, or it was thought to be very symbolic. It was, of course, also recorded, um, interestingly, by the Chaco Native Americans in New Mexico. It was recorded in Italy. It was recorded in places all over the world. Pretty interesting times. And of course, 1066, the comet wasn't well understood at that time. This is before, of course, Halley's comet and Newton's use of that to sort of kickstart the laws, the Newtonian laws of gravity, I should say. But it was 1066 today, actually, so May the 6th, and it was a nice one that's happened, I suppose, somewhat recently, and of course with Comet Pons Brooks, just barely visible still in the northern hemisphere. It's a great time for comets. It's a great time for meteor showers, and it's fun that this one was, 1066 on today. And here we are today with the peak of the Eta Aquarids, which were caused by Halley's Comet today. So that's, and that was a literal peak happening now. So if you're just wondering, the Eta Aquarids meteor shower, that's the one that's happening this year, 2024. The peak was the May 5th through the 6th. So if it is clear tonight, and you happen to be out, it's radiant below the horizon now, but it will be rising around about of, let's see, probably around about of 2:53 a.m. So you'll have to stay up pretty late, I think. Anyways, a little bit of fun for meteor shower aficionados. Have you seen the Eta Aquarids, Mary Helen?
No, I haven't had a chance. It's sort of like it's been either raining or very unpleasant weather for wind and cold the last uh couple of days. So I haven't really been out to look, but maybe after this I'll have to go out and take a peer around because it does actually look like it's staying fairly clear up here tonight too. So
Yeah, and of course the radiant below the horizon, that will be until about 2:30 a.m. It's not going to be really good until just before sunrise. So it might actually work better for most people if you're planning on catching the Eta Aquarids, getting up early rather than trying to stay up until they're really good. So 4 a.m. Just before sunrise, and of course, just as nautical twilight is starting at 4:48, that might be even better. So I don't know how hard it is for other people to wake up at 4 o'clock in the morning. But for a little bit of a teaser, the Eta Aquarids are supposed to be pretty good this year. We're expecting up to 50 meteors per hour. And it's a nice Aquarius-based meteor shower. It gives you a chance to see, if not the comet Halley, at least some of its, I suppose, residuals slamming into the atmosphere of Earth as we try to mind our own business and go around the sun. All right, so I suppose that's one fun one. Of course, meteor showers, we have a bunch that we can talk about later. I know that you have some some expertise in this, at least with the rocks that land. Have you found any interesting landed, I should say, meteorites?
I personally, no. It's one of those like really rare things, and in this part of the world, they're incredibly hard to find because, of course, you can't distinguish them easily from sort of rocks that are on the surface unless you trip across something that's like an iron meteorite that's clearly quite different. So most of probably a lot of meteorites that have hit the ground, people don't even recognize what they are unless they're in a key, they're in somewhere where it kind of stands out or their physical properties stand out.
Yeah,
So
and that's it is worth noting this is generally they are harder to find, but if you do find an iron meteorite, those ones I think usually you can kind of tell it's a bit funny because it's quite heavy, right?
oh yeah, they're quite heavy. Um, they typically have like an almost melted appearance to their surface, and they'll frequently, if they've been sitting on the surface for a while, they'll actually have bits of rust on them, right? Because it is just pure iron, and if it sits in Earth's atmosphere, it will oxidize over time. But the big giveaway is the weight of these things. The other thing being is, if you really ever want to be sure, if you cut the thing open, you'll see the very distinct crystallized iron pattern. That's sort of the dead giveaway, um, that you're actually looking at a meteorite. Now, meteor showers don't produce anything that hits the ground. It needs to be something bigger than that. But you do get fireballs once in a while that do leave pieces uh, various places on various places on Earth. So
Yes, exactly. And so if you are out hiking around or you do see something strange, maybe that's one thing we can have everyone look for. And of course, if it looks really, really interesting, you can always try to bring it in somewhere and have have someone look at it for you.
yeah, the ROM used to have a program. I don't know if they still do. I haven't had contact, but it's places like that where you can take them and they can actually, you know, usually diagnose if it probably is. Don't be able to tell you for sure. So, but they that's where you'd find the expertise to look at those kinds of things. So,
Absolutely. And I'll just say, on our way to our next little This Week in Space and Astronomy history, I'll just mention that the clouds have in fact moved out of the way. So if somehow you're listening to this broadcast and not able to see it on YouTube, join in now for live images from the 1 meter telescope. I believe it's on Merak, but you can find out by joining in the chat on YouTube live for some lovely imaging from the telescope. So, very pleased we managed to get some clouds to move out of the way. All right. So, moving around a little bit, I thought, it might be fun to go back in history one more time. And of course, one fun thing that we can also talk about, in addition to the meteor showers happening and things you can see in the sky right now, well, actually, the sun is still pretty interesting. So I thought, well, maybe for our next jaunt back in time, I'll go ahead and talk a little bit about the sun. So, the sun, as most of you know, has been very, very interesting recently. You'd have to almost be actively trying not to listen if you didn't hear about the April 8th eclipse that recently happened in Toronto. Very, very exciting. And of course, that solar eclipse was a great reason to go out and, I suppose, look at the sun safely with safety solar glasses, I should say, which is what we were telling everyone. Just don't look directly at the sun unless your eyes are protected. But the sun is interesting for a lot of reasons, and one of those, of course, is its solar cycle, which means that it can go through active and inactive periods every 11 years. So the solar cycle is means that we have chances of catching interesting things, and yeah, right now is actually pretty good. Also, if we go back to 1921. So this is the closest large solar activity I could find for this day in history, almost. So if I add 4 days, that gets us to the 10th of May. And 10 May 1921 was a pretty fun one. This was the New York Railroad solar storm. And there have been all kinds of interesting solar storms. But the 3-day event on May 1921 was also called the New York Railroad Storm. And this was caused by the impact of a particularly powerful coronal mass ejection. And now this is one of, I suppose, three main things that you can look for on the sun if you are doing safe solar viewing. You can look for flares, you can look for prominences, and if it's a really large bunch of material coming off the sun, you might even have a coronal mass ejection, which is a significant ejection of magnetic field with plasma and all kinds of interesting stuff coming off of the sun. And that means a lot of stuff going through space that, if we happen to be in the wrong place at the right time, some of that might impact Earth's magnetic field and our atmosphere. So that means Earth's magnetosphere tries to funnel the material into sort of around the magnetic field. We get spectacular northern lights. But if it's a coronal mass ejection, it could be a lot of material and it can have other things happen. So if you probably heard about the Carrington event, well, this May 1921 event was not as powerful, but on May 10th, there began to be a large, large sunspot. And this is how a lot of events do start out. There was a sunspot that came about on May 10th and was very, very large. It actually has a name. So this was AR 1842, began on May 10th. So this is what happened in 1921. It started, and we think it's caused the storm. So by the 13th of May, so 3 days later, it actually was impacting or partially impacting Earth's magnetosphere. Now, this was part of what was called solar cycle 15, because of course we track this going up and down of the sun's cycle every 11 years. Solar cycle 15 is the 15th solar cycle since 1755, when we started actually trying to record sunspot activity, or that's at least that's as far back as our paper records go. Other sunspot records we just don't have. So we've been counting solar cycles since 1755, and solar cycle 15. They all have a little bit, different timings. This one lasted 10.1 years, beginning on July 1913 and ended 1923. And so that means, of course, that 1921, you're close to that end, you're close to that maximum. But the maximum number of sunspots was actually 1917. So this large storm didn't occur at sunspot maximum, but there was a large sunspot that was generated that caused the large storm. So just to make things interesting, the sun is very, very dynamic. It's a giant ball of heated plasma. It does all kinds of interesting things. Now, the minimums activity, so when you have the least sunspots, that can be no sunspots at all. So you could have, days and days with no sunspots. And the minimum transit from solar cycle 15 to 16, they said that there was a total, adding it all up, of 534 days with no sunspots, that's a lot of days with no sunspots. But of course, 1921, this is when they had the interesting thing happen. So you're not at the sunspot maximum, but there is a large sunspot that was formed. And of course, this intense geomagnetic storm was generated by a coronal mass ejection coming off of the sun. So 3 days later, it impacts the Earth on the 13th, 14th, and 15th. And over those 3 days, the storm's electrical current was actually enough to spark fires. And of course, this is 1921. You do have to wonder what would happen if this hit us today with all of our much larger number of electronics running around, which is, of course, the same question you could ask about the Carrington event or the Quebec event. But contemporary science puts the size of of that sunspot which generated the storm at about 151,000 kilometers or 94,000 miles. So nice and big. The storm, the electrical current sparking fires, this actually occurred all over the world. And one of the most famous fires that was sparked by the electrical current causing literal sparks in wires, electrical fires, was actually at Grand Central Terminal in New York, and that's why it became the New York Railroad Storm, because Grand Central Terminal in 1921 was a major big deal. And of course, a fire getting sparked by activity from the sun was pretty unusual.
Yeah.
So
Yeah,
very strange stuff.
oh, sorry. The other interesting one they got too is telegraph operators, because you talk about the communication thing. In that day and age, you didn't use phones really, you used the telegraph, and there
Yep.
were sparks and people getting shocked off the telegraphs in some parts of the world, because we were getting these current surges through all the wiring that
Yeah.
connected things. So that when you talked about communication, it's like it's been affecting communication for longer than you think. It's just, instead of being hardwired, you're now wireless. But it had those effects even back then. So
Oh, yeah, and of course, in 1921, they were able to see telegraph services slowing and then actually completely stopping on the 14th of May. They had damaged equipment. They had radio issues, so using radio waves to propagate signals. They actually found that radio propagation was enhanced. So you had unusually good long distance radio reception for a while. Um, and undersea telegraph cables. So not just causing sparks for operators, but actually using the telegraph systems with these undersea telegraph cables. The telegraph systems were damaged, and of course, the systems in Europe and the southern hemisphere were also noted as having been damaged by this storm. And you do have to wonder, like, okay, well, we have a lot of undersea cables now that are responsible for the internet as we know it. How well are those insulated? But of course, this particular storm was big, but it was not, for example, the size of the Carrington event. So you know, very large storm, but not the largest. But still, back in 1921, this was a pretty big deal, and it would be, I think, a major deal if one of these did impact today. So I don't know. So keep an eye on your solar weather, I suppose, everyone. But that's the May 21 geomagnetic storm, all the way back in telegraph times. Now we have a couple fun news stories as well. Oh, do you have a good telegraph link in, Mary Helen?
no, not sort of a telegraph link in, but yeah, I mean, some of that is sort of cycle dependent, and the chance actually right now of getting one this big is pretty low because the solar cycles have been kind of quiet the last couple of years, but that could change anytime.
Yeah, and it's worth noting, of course, as you say, it's these particular events, the really large coronal mass ejections, they don't seem to be correlated with the solar cycle very well. General solar activity is correlated with the solar cycle, and you can see that in the number of sunspots. But predicting the really large events is a lot harder because they
Yeah.
don't seem to occur at any particular time of the solar cycle. They just happen. And so this one was not during a maximum at all. And of course, the solar cycle that we have now is linked up with the solar activity that we are seeing. So there's been some nice sunspots. If you were out viewing the sun during the solar eclipse, you might even have seen one if you had a large enough viewer. Uh, but there were not hundreds and hundreds of sunspots, but there have been some really interesting large groups, and of course, some spikes in the northern lights that correspond to that. It is worth noting that now we are currently in sunspot cycle 25, and the actual maximum of sunspot cycle 25, which is the one that we are in, we're not quite sure of. It could be this year or it could be next year. It sort of depends. And we won't know until, of course, the number of sunspots starts going back down again. All right. So this is about halfway, I suppose. Good time to move on to some of our fun articles that we've marked off. Let me go ahead and actually remember to do the announcements. So let me go ahead and just remind everyone real quick. We are about the halfway mark, and you are listening to York Universe, broadcasting live from Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory for any kinds of extra archives or information or links to the YouTube and all kinds of good stuff, as well as our donate button. And tonight you're listening to Mary Helen Armour and Elena Hyde, and we're discussing right at the moment solar cycle sunspot stuff. So stay tuned to this channel, and we'll keep you all updated. Now, a couple of little announcements before we move on to, I suppose, the news part of our show. This Wednesday is an Arboretum Atrium tour in person. So if you are coming by the observatory, for live tours on Wednesday night, please make sure to go to the Arboretum parking garage. Do not go to the Petrie building. It will be at the Arboretum parking garage. Also, of course, this being May, the official Astronomer in Residence program for 2024 has begun. So you will find some updates on new astronomers and adventures out at Killarney Provincial Park on the website. You can go to the same exact website I've been telling you all day, and then just go to Astronomer in Residence, or AIR, AIR. Final little announcement for the channel. We will not be having any more Twitter accounts. You can connect with us on Instagram at York U Observatory and Facebook at Allan Carswell Obs, but we will be placing a hold on Twitter, or what has become X. So if you're following along on social media live, check out our Instagram, because that is where York Universe is going to try to keep up with the live streams. So let us know how it's going. And speaking of live, it looks like we have some excellent live images coming in from the telescope. We've had a few different objects come by, and I think it's going to be Fecta next. So make sure to check that out on the YouTube if you haven't seen it yet. You can always go backwards on the videos, which is one of the nice things. All right, so let's get some news items. So I see that there's been some wonderful space weather news. So Mary Helen, you've put down some cool space weather stuff. Do you want to talk about some of this sunspots and flare activity?
Yeah, so the last, I mean, not tonight, but last night there was a possibility people may have seen aurora. I mean, it depended on your weather, but certainly if you went up north of here, you probably would have seen it. There has been some activity the last couple of days because there was, I think, a small coronal mass ejection that kind of hit Earth around this time, or at least a lot of activity. So, you know, this is when we get the aurora, and it looks really pretty, but from the point of someone like myself who does some magnetic surveys and magnetic work, it's a real pain because when it gets too active, we can't do surveys because there's too much noise. Now, the past few years have been good because the solar activity has been very low. There have actually been an awful lot of spotless days, which has led to sort of very quiet. So over the last few years, seeing the aurora has become rare, but it seems to be that right now we're getting more activity. So, you know, maybe over this summer, there'll be some better possibilities. Because it's like I said, the last 24 was a very low solar cycle. And 25 doesn't look like it's going to be that high either, which means fewer aurora events. But generally means there's less interference with communication. So our cell phones don't die. I mean, since cell phones came along in around, I guess, late 90s, 2000, the solar cycles, you know, the last 20 years have been pretty quiet. So it'd be interesting if you get really high activity or a lot of sunspots and a lot of activity, what would happen to everybody's cell phone. I mean, there's some great websites like Space Weather and a couple of the places down in the States, like the National Oceanic and Atmospheric people and NASA all have websites following this because it has implications for a lot of communications. So there is information out there to follow it. Cycle 25 might be peaking, or it may not peak until 2025. It's a little bit unclear because it's roughly 11 years. It's not exactly
Yes,
11
that's
years.
actually a very important point with the solar cycle. You don't really know exactly what it's going to look like until it's passed.
Yeah.
Um, there's some error bars on there for sure.
So, but like I said, in the 50s and 60s, it was quite active. And then, as like you said, in the 70s and 80s, there was that massive event in 1980 in Quebec that fried part of their power system and caused massive power outages. Uh, but nothing really major since. But you wonder what kind of effect something like that, like, the level of the New York or the Quebec event would have on modern communications technology. Now, we've gone to a lot of fiber optics, which shouldn't be affected, but any kind of like cell signal or Wi-Fi or anything like that
Yeah, well,
could
that's
really
exactly
mess
right.
up.
As the cellular network has gotten so huge now, a lot of people don't even have landlines, and we kind of know how landlines will be affected. But what exactly will happen to cell service? I mean, there's probably some research on that somewhere, but I haven't seen a lot about it. So,
Well,
yeah,
just when,
interesting.
yeah, I mean, if you've got a lot of extra energy in the atmosphere, you can have a lot of extra electrical energy. It's going to interfere with the signals. And the thing is, we also rely a lot on satellite communication, and that would certainly be messed up because the satellites themselves could be damaged, especially some of the ones that are at much higher altitudes. So
Yeah,
I
the only
know.
thing we know for sure is that radio reception would actually get really good. So it might be, maybe we'll get radio broadcasts, like a return to radio shows. For, I don't know. Um,
Yeah, I mean, shortwave radios tend to perform better, and part of that is because of the way they can bounce off the ionosphere better when the ionosphere is more active, right? So you create sort of I guess, an electrical mirror in some ways for these things to bounce around. So you can get shortwave from almost the other side of the globe. So, but nobody uses shortwave radio much anymore.
no, exactly. And that's, I mean, and I was just checking, you're absolutely right. So if anybody's curious to look at how these solar cycles behave, the NOAA website is an amazing resource, and NOAA.gov, they actually have really, really good details on solar cycles going back for, quite a ways. And of course, if you're interested in tracing back the history through 1750, you can. They have the whole set of data that you can scroll through, and it's somewhat unusual, at least recently, to get a solar cycle with sunspot numbers that go over 200. Now, of course, 2000, there was a couple times it went over 200, 1990 a couple times, 1980 a couple times, but then it wasn't, even those, there was nothing above 300 until you go back to 1960. And that's a pretty big difference in the
Yeah.
the general sun activity level, and all of this, won't affect the temperature as much here on Earth, but it will affect things like, of course, atmospheric activity and this noise that we see. So yeah, it is very interesting to play around with, and if folks are curious, I can definitely recommend going on and checking out your favorite solar cycle. And even if you have a favorite coronal mass ejection or a storm you want to look up, that's actually where I went to to see what it looks like for, of course, the famous events. So, for example, the Carrington event which was one of the, I think, still the largest one we
Yeah,
have data for.
I don't think any of them have come.
Yeah,
Well, at
it's
least recorded
eight,
ones, right?
yeah, 1859. Amazing. That year did not even have 200 sunspots at its peak, and yet it had 1859 largest event that has been recorded. So that was just as a little bit of I don't know if someone hasn't heard of it yet, I suppose. This was found by Richard Carrington, who was an astronomer. He was looking at the sun safely, which you could do in 1859 with projection techniques, and he was examining sunspots. And as he was watching it, he saw a bright white light that was almost certainly a coronal mass ejection. And less than 24 hours later, the skies all over just erupted in amazing aurora. You had not just, a little bit of green, you had red, green, purple, so bright that newspapers could be read at night. Stunning auroras, even at tropical latitudes, so not just
Yeah,
at
it
the
was.
poles. They had telegraph systems going completely haywire, spark discharges, at a much higher event than anything else we've talked about. And of course, even with the power off, they could unplug their telegraph, and the electric currents in the wires were high enough they could still transmit messages. They had wireless power due to this event in 1859. Amazing, and I mean, telegraphs were pretty cutting edge in 1859. And that's the kind of event like you have to really wonder, wow, what would happen if this occurred again? And of course, in solar storms, there have been notable events all over. I think one of the most scary ones that I read about when I was looking at solar storms was actually not even the Carrington event. It was the 1967 solar storm that caused a blackout of surveillance radars during the Cold War, and it led the US military to scramble for nuclear war until the solar origin was confirmed. So it was a solar event that caused an outage in polar surveillance radar that almost caused a nuclear war because people didn't know what it was.
Yeah, they had.
So
Yeah, when you look at it, even the 1980 event, because it hit Quebec and it hit North America, there
yeah.
was some of that speculation at that time too. Now, by then, the technology improved, so they could, figure out faster what had happened. But it was the same kind of thing, and some of the effects of these kind of bursts would be similar to, the EM pulse you'd get from a nuclear explosion. So it would be hard to tell them apart just on a quick, you know, reading. All you know is you've got this big pulse. Technically, it could potentially be from a nuclear explosion too.
Yeah, and fortunately, thank goodness they took the time to verify it, and it it was in fact, from the sun. It's not a and we did not have a nuclear war from it, but oh my gosh. Yeah, it's I think it was one of the more scary ones because it's like now, if we had massive communication failures, you'd hope that they would also make sure that it's not due to um,
Every
a solar
teenager
event.
on the planet would go into shock when the TikTok goes down.
Oh my gosh, I know. Um, but yeah, it's very very interesting stuff, and of course in the Sun News for May, it's actually, as you say, it's been pretty interesting. I actually saw that there was an X 4.5 flare today, May 6th. So I'm just checking it. This is May 6th. It's definitely May 6th. It was an X 4.5 flare that came after an X 1.1 and an 11M. So you have all these interesting flares happening. The X flares are some of the most powerful flares for flares, and not coronal mass ejections, but still just a flare. So there have been some interesting eruptions in recently off of the sun, and of course there have been some fairly large sunspot groups coming around. So we can hope that this will just give us beautiful aurora and few other problems.
And it also depends with the flare on which direction it goes out at, because you could see a flare, but if it's not Earth directed, then it's nice to see the flare, but you'd have very little effect here on Earth, right? It depends on where it's actually directed to,
Oh yes,
particularly with
absolutely.
flares, because particularly with flares, since they're relatively small. Yeah.
Yeah, and it's worth noting as well that there have been other coronal mass ejections since the Carrington event that scientists think would have been a Carrington-like event if it had impacted Earth. But fortunately, space is huge, and it takes some effort for us to run into these things. It's like the Earth is very small. My favorite solar system model is still just the get a very, very large grapefruit and then like the smallest poppy seed you can and go put that poppy seed at the appropriate distance away and you'll get a good chance of seeing why we don't worry too much about these unless they're directed pretty much right at us. Glancing blows are also a thing, I should say, though.
Yeah. Glancing blows may actually be worse for satellites than any kind of surface effects, because once you get up high enough, I mean, particularly the some of the geostationary, geosynchronous satellites, they're even above some of the Van Allen belts that might provide some protection. So they're the ones that would be probably hit the worst, just because they're outside of the and not quite outside the magnetic field, but high enough up that you're not going to get the same kind of protection as something like in a low Earth orbit.
Yeah, absolutely. And it's worth noting is, satellites and astronauts and the International Space Station, all that stuff up there, they do have, sort of solar protocol, I suppose I should say. So if there is a solar storm and you're on the ISS and you can't come down, they have, I think it's a shielded area or a shielded room. That will provide more protection because you don't actually want to encounter highly energetic particles. That's pretty bad, very cancerous. So it's unlike in the comic books. No one yet has ever gotten superpowers from encountering anything like this. It's all just bad. But yeah, the satellites have a pretty high rate of falling down if they've gotten hit by these things. And I think I remember hearing something like one or 200 Starlink satellites burned up on the last big set of activity. So that's a lot of satellites to burn up.
And those ones are fairly lower orbit too. Like they're not in the really high orbits either. So
Yeah, yeah. Yeah, exactly. And so you hope that if you've got a really good satellite that you want to keep, you retain some maneuverability, and you can, if you can move your satellite, if you have any ability to move it, you can watch the space weather and say, oh, I see a coronal mass ejection or a flare or some activity on the sun that is headed straight to Earth, and you have some time to prepare because it takes a while for that material to reach us. So if you're fast enough, you can just move your satellite to the other side of Earth and get some protection from the planet.
yeah. I mean, a lot of them will be built with some kind of protection. They can also shut some of them down temporarily, which can give them some protection if they're not actively transmitting. Um, it does make it less likely to get fried. Less likely.
Yes, yes, exactly. And of course, watching the space weather is always fun. If you go on the live views for the sun, one thing you'll note is that they have a lot of different wavelength views available, and so you can see how different parts of the sun's plasma and atmosphere are responding to things like a sunspot, for example, looks very, very different in X-ray than it does in quote unquote visible light. So there's some cool features you can see if you did happen to see, and this is just a little shout out. So if you were extremely lucky during the total solar eclipse and you happen to be in totality with clear skies, you could have seen with your naked eye, possibly prominences, um, maybe even a flare. There was actually a flare for some folks in totality in Ontario, that actually happened during totality, which was crazy. But most notably, you can see the corona, which shows really beautifully the magnetic field parts of the sort of the outer part of the sun that you don't usually get to see because the photosphere is too bright. so, so there's some fun overlap, of course, with the recent solar eclipse event. That said, if anyone still needs eclipse glasses, we do have one or two left over. So we'll probably bring those up for the next solar observing event at the atrium. All right, I think we have time for probably one more sort of news item to go for. Do you have another one that you wanted to cover?
I think you had the meteorite hunt ones that had come up lately.
Yeah,
They
I
all,
thought that might be a good way to tie in. So if we did the sun first, we've talked about the sun, we've talked about the solar cycle. Of course, one thing that we can say about the solar cycle is that there's no known correlation or causation between the solar cycle and what we've measured for global warming. But we can connect up with meteorites, and in particular meteorites in Antarctica, because of the warming, especially in the Antarctic. Meteorites are actually getting harder to find, and this is something that's more Earth-based, but also meteorites are pieces of outer space that have landed on Earth and going to places like Antarctica. They actually used to be quite easy to find. You could just about walk around and just sort of pick them up. I've never been to Antarctica, but I've heard that's the case. So I believe the people who went there. But unfortunately, with the climate change warming the poles, and especially warming the poles so much, Antarctic meteorites are starting to melt down into the ice, and they're actually melting out of reach. So
yeah,
it's one of those things that you wouldn't necessarily think would be affected by climate change, but finding meteorites and meteorite fragments is one of those things that's about to get a lot harder. So meteorites, just as a reminder, we talked about, of course, meteor showers. These are fragments that survive going through Earth's atmosphere, and they land as, usually somewhat scorched blackish rocks. Might be a little bit heavier than you thought when you go to pick it up. And they've been used to study, the icy outer solar system, the formation of the solar system, and Antarctica in particular has provided about 60% of all meteorites collected. Now, the what they're worried about is that they're losing the meteorites faster than they're collecting them because with the rocks sinking deep into the ice sheets, they're not going to be very easy to collect. There's about, I believe, something like 80,000 that have been thought to have been
yeah,
collected so far.
yeah. It's quite a large number, and some of them are quite scientifically significant because some of them are getting even blasted off of the other planets in our solar system. Quite a few of the Martian meteorites we have found that. I mean, the most famous one, of course, was the ALH 84001 that for a while, you know, famously or infamously was thought to have traces of Martian life
Yeah, the little
on it.
worm things.
Yeah, and it was interesting. I think they overanalyzed it, but it was quite. I mean, but this was one of those. Allan Hills is one of those areas in the Antarctic where they were looking for them, and it's like I said, it's kind of like the poor man's. I think they talked about it in a couple of the articles. It's sort of like the poor man's spaceship because you can go there and find these meteorites. So I guess it all started with a Nature article back in April, and a number of other places have picked up on it. But it's actually quite significant in sort of the meteorite community because they've collected so many from there. And if that source dries up, you're like, uh-oh. Because it's much harder to find them. And you don't find them equivalently at the North Pole because the North Pole is polar ice, not an ice sheet. So it's a different kind of scenario. So you don't get them at the North Pole the same way you get them at the South Pole. So
Yeah, exactly. And it's that I don't know, sort of that pristine surface that meteorites can land on and stay there and be found. But yeah, the number that they're currently looking to lose is potentially all of them if we go too far. But the thing is with meteorites is like, yeah, okay, they've collected quite a few. They're getting some every year, but you never know which meteorite is going to hold the next really big discovery until you take it home and analyze it, right? And so losing these meteorites, it's kind of losing a whole regime of exploration. And of course, they've mentioned, of course, as you mentioned, the Nature article. If you guys want to look this up, it's the Nature article was all the way back from so April 8th, I think it was.
yeah, it's
Yeah,
April, and that particular Nature article is open access, so anybody can read it.
which is the best. I love open access articles. And yeah,
Yeah,
this was the one published by Veronica Tolinar et al. Antarctic meteorites threatened by climate warming. And that's I think a pretty convincing paper. And of course, with a major source of meteorites, um, potentially being lost to us, this is, yeah. I mean, it's going to be a while before we can do reliable sample return from things
yeah,
like Mars or anywheres. I mean, I don't know if folks have been watching the sample return missions, but it's only just recently that I believe NASA and some of the other agencies have said, actually, we're not sure our original sample return for Mars mission is going to work how we set it up. So they had some sample canisters being put on Mars or created on Mars, and they were hoping that they could leave them there and pick them up later. But there's some serious doubt as to whether or not this plan is going to go ahead at the moment. And sample return from the moon still remains a real challenge. There have been so many moon landing and mission failures recently. It's hard. It's really really hard to bring things back from space. And the recent success that we had, gosh, I'm just forgetting that. Shoot, I shouldn't be forgetting that asteroid's name. Recent sample return mission success trivia for anyone in chat. um, but it's extremely difficult to bring things back from space, and you get just tiny tiny grams to analyze.
yeah. I mean, it's like I said, that's why the Apollo moon landings. I mean, they brought back hundreds of kilograms of rock, and that's kept a lot of the lunar stuff going for a while. But I mean, now you're talking 50 years ago almost since the last
Yeah.
lunar landing, and that was quite a trick in and of itself. So yeah, it's losing that source in the Antarctic is more serious than maybe people would think about. And they're like, well, it hits other parts of the earth. Yes, it hits other parts of the earth, but 70% of it's water, so it sinks. Anywhere where
Yeah,
there's
exactly.
anywhere where there's vegetation, the chance of you finding it is slim. And if there's a lot of life activity, it can be seriously compromised by earth contamination.
Oh
Um,
yeah, yeah, and that's actually a little. Anyone who played along with the trivia before the mission I was thinking about was the Osiris Rex, which I should remember because it was Rex and it fetched. That's how I remembered it last time. But it did actually go ahead and bring back a sample from the asteroid Bennu, and it was just we're talking just grams of this asteroid, and it was a massive, massive deal to bring back a tiny, tiny little bite of this asteroid. I think Canada is set to get a very small piece, but it's being analyzed like microgram by microgram. It was um, it was a tremendous achievement, but it brought back such a small, small sample, and we
Yeah.
don't have anything else coming back again soon.
I mean,
um,
your hope is then you get some kind of fireball that strikes. I mean, the
yeah,
famous
exactly.
ones like the Allende meteorite and the Murchison meteorite really, really helped scientific progress because they caught them fairly soon after they landed. And there was the Tagish Lake in northern Canada a few years ago, and of course that Russian fireball.
Oh yeah.
And that's sort of the only other option you have is sort of waiting and sitting hoping you catch something, rather than this reservoir you have sitting in some of these open areas of Antarctic. So it's like I said, it could put some major dents in some of that planetary exploration because you don't have that sort of reservoir of stuff that's easy to find because the rocks stick out on the snow.
Yeah, yeah. So, I mean, you heard it here, first, folks, or I don't know, not first. The Nature article was first, but you heard it here. Save the meteorites. Um, all right. So, on that note, we should probably wrap up for tonight. I hope you all have had a good and clear evening. Get to see some of those fun objects that we've been showing through the 1 meter telescope. Thank you for joining us. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Professor Mary Helen Armour and myself, Dr. Lena Hyde. You can always connect with us on Instagram at York Observatory and Facebook at Allan I Carswell Obs. Just a reminder, we are no longer on Twitter, but you can always check out our website for show notes, content updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.